Hello, and welcome to this panel discussion about keeping workers safe in the IoT as part of our Defining the Smart Manufacturing Journey series sponsored by Rockwell Automation. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Defining the Smart Manufacturing Journey series, Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look at the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I'd like to pass things along to Edgar to lead us through today's discussion on keeping workers safe in the IoT. Edgar, welcome to today's event.
Thank you, Katie, for the introduction. My name is Edgar Sauter. I'm a Senior Director of New Product Technology at CSA Group, and I will be moderating today's panel. Smart manufacturing promises to make a safer place of factories for the workers in the factory floor. But that doesn't come without challenges from the implementation and even risk. Today's topic will be that. We have a set of experts in different areas that will talk about this topic and share their ideas with us. So with us today, we have Mohsen Sefer. He is a manager for new product technology at CSA Group, where he develops testing, inspection, and certification programs. He holds a PhD in electrical and computer engineering, as well as an MBA. He has 15 years hands-on experience in advanced technologies in a variety of manufacturing disciplines. We also have with us Tim Shimbara. He is the Chief Technology Officer for AMT, the Association for Manufacturing Technology, where he is responsible for industrial research and development, standards, and technology discovery. He has ample experience in U.S. manufacturing technology, including policy development. We also have with us Dean Phillips. Dean brings 34 years of smart manufacturing experience to this panel. He is an advisor to the SME's Smart Manufacturing Advisory Committee. He is an accomplished speaker in IoT, AI, robotics, and AR and VR. He is also an entrepreneur and has served on the board of directors or as an advisor for multiple technical committees. We also have with us Mario Ishikawa, who is the CTO at PAC IoT, a software company focused on digital transformation for manufacturing. Mario has been working with industrial software such as SCADA, Historians, MES, and SPC for the past 24 years and leads the Smart Manufacturing and IIoT division of ISA on AR and VR. And we have Paul Brooks, who is Manager of Technology Business Development at Rockwell Automation. Paul has held multiple leadership positions within ODVA's marketing and technical community and currently sits on OPC Foundation's Marketing Control Board and is a member of the U.S. Technical Advisory Committee for the IEC SC65C. He is a chartered engineer and holds a degree in electrical engineering from the University of Leeds. Well, Dean, Tim, Mario, Mohsen, and Paul, thank you very much for being here today with us and share your knowledge and experience with our audience. So as just said, smart manufacturing promises to improve safety at the factory floor. But how is that implemented? And what are the risks and challenges that companies have to address to make this a reality? So this will be the conversation of our panel today. I'm really eager to know your thoughts about it, and also the audience to bring your questions about the conversation. But before we begin, let's have some words of acknowledgement to our series sponsors for today. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell's inherent expertise in industrial networks, sensing technologies, and digital software means it is one of the preeminent authorities for everything related to smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. So now, without further delay, let's start with our panel discussion. And I want to start with a simple question to our panelists, basically to open the whole conversation. And it is, how does smart manufacturing address safety in the factory floor?
So I'll take a shot at that to start off with. When we look at smart manufacturing as IIoT, in the context of safety, we have to remember that every workplace incident is a result of a chain of events. And what machine learning is all about is identifying the relationship between causes and effects. So as machine learning algorithms start to identify these workplace incidents, they start to work out the chain of events that lead to them, and they can then identify those chains of events and give warnings about incidents before they happen. And that's doubly valuable when the incidents that they've learned from haven't happened in the same plant, haven't happened in the same country, haven't happened in the same user. By being able to learn about the chain of events that leads to incidents across a wide geography, we're able to really spread the lessons learned. We're able to minimize and mitigate risks on a much wider variety, much wider geographical basis, because we're institutionalizing the lessons learned, automating the lessons learned.
Thank you, Paul. Now, like this registration of events to learn from problems is already taking place in many factories. Like there is a record of what happens. What is it different from the process that these companies already have to register the issues and problems and accidents or risk compared to what IIoT or smart manufacturing can provide?
Okay, can I take that
If
one?
you don't mind, I can.
Of course, Mario.
Oh,
Go ahead.
Yeah, start off, Mario.
Okay, I would say that it can be as simple as just start breaking the data silos, because usually in the process, what we have, although we might have some good amount of data, we have them stored in specific systems. And as Paul mentioned, machine learning and all this data in a data lake being used by, let's say, business intelligence tool, they need to be leveraged by IoT in the sense this data has to be shared and it has to be available for the ones that need to take insights from this.
Thank you, Mario. Tim, you were going to mention something?
Yeah, following the same lines as Mario, I'll go another couple levels deeper in what we have seen as far as information modeling. So when you look at IIoT, what we have seen is the gain in really situational awareness. So we now have instrumented well with sensors in different areas where we didn't have sensors before, or at least not prevalent, and certainly not as pervasive. So we look at that almost like getting to our third, fourth, and fifth why question, the 5 why exercise. And so if we can grab all of that data in areas we didn't have it before, and then we can model that data with an information model and semantic dictionary, once you're in that lake, so not everything will always be disparate. We do need context. We do need definition. When you start to line those things up, the increase in situational awareness provides our ability to apply machine learning and do the different algorithms that allow us to see what are anomalies and all the things that we try to find that we wouldn't otherwise have known. So I think, one of the biggest trends we've seen recently has been the layer of the context and the amount of the data that are coming from the pervasiveness of the sensors in the IIoT world.
Got it. Thank you, Tim. Now I have a question. Imagine that I am a factory owner or the owner of a company. I want to implement that in my factory floor. I want to start with that. Let's say smart manufacturing for me is not too much about production. I want to make my factory safer. What are those technologies that I have to think about to start to bring? What are those technologies that will help me get to smart manufacturing from a safety perspective?
Can take that one.
Sure. Thank you, Mohsen.
The most important elements of implementing safety is using one of the main structure of the IIoT, which is the advanced sensors. That's a practice that could bring the backbone of the structure for the creating a safe environment by implementing those advanced sensor into the manufacturing as they are using already in part of the IIoT, and trying to somehow integrate those sensor data with some sort of further analysis or computational or computer vision and create more accurate information. The type of the sensor, it can go beyond the type of the usual Internet of Things or IoT application, because majority of the type is placeable sensors that you place it in a specific location based on the deliverables that you expected based on the process in the manufacturing. You can go beyond to that and reach to the wearable sensors that can be attached to the workforce in order to analyze some sort of critical data. For example, for the people who work in a very hazardous location or something like that, or dealing with high temperature, these wearable sensors can provide some sorts of temperature-wise, some sort of analysis that can be applicable. Some advancement is happening to have an implantable some sort of sensors that can be implanted inside of the body, considering some of the operations that you are going to experience, which can have for some advanced application as well. These are one of the main initial approach that we can say the smart sensor, advanced sensor can play a really important role for that structure of the creating a very health environment in the IIoT for the workforce.
Thanks a lot for that, Mohsen. I'd also like to think of the same problem from a slightly different angle and think about the way that virtual reality and augmented reality can also directly support the worker. By presenting them a virtualized image of what is happening inside of the equipment, by presenting them information that is complementing what they're seeing. What we can do is we can reduce the amount of physical interaction that the worker needs to have with machines, because we're presenting them with that virtualized image, that virtualized representation, rather than them having to physically get inside equipment, to physically open equipment. So in addition to instrumenting the worker, detecting the worker, I'd also like to make sure that we focus a little bit on how we can present the worker with information that enables them to operate and to do their job in a more safe manner.
Thank you, Paul. Now, Dean, you work with a lot of manufacturers, like the cases where they have implemented these technologies. Is there any example that you can give us of a case, or even mention a trend where these a trend in the industry where technologies are being used for safety purposes?
In and around a lot of the manufacturers, they all have a goal of implementing their sensors and taking them to the IIoT levels. One of the challenges that they have, though, is how do I apply this? How do I make this actually happen in real life? There's some challenges you have here within this manufacturing environment where you take the sensor level. there are some delays that you have with a lot of the sensors to take it up to a cloud level and then trying to process that information. It works best of having, and we talked about this on one of the other sessions that we've done, which was talking about loops. When you think about loops, you have a loop at a local level. So for the hard sensors where you're actually trying to make sure that an operator is safe when they're reaching into a machine, you're talking about, in OSHA world, they talk about 16 milliseconds equals 1 inch. You 15.9 milliseconds for 1 inch. So for every 15.9 milliseconds of delay, you need to move away 1 inch. So you can impact your safety distance. How far are things at the proper distance when you start talking about that? However, a great application for things like IIoT and safety is what we've talked about already here, which is, how do I realize what we're doing correctly and reinforce those instances? Perfect example is we had an instance where we were trying to trace out a problem where an operator kept going and getting into an area they shouldn't have been. Well, they were coming in through a rear gate using the sensors on the back. They were interfering or breaking the sensor on the back. Everybody else was coming in from the front, but for their practice, because of where they were loading the tool, it was easier for them to come in from the back. And it wasn't until we got that IIoT information back to actually analyze and see what was going on that we realized that they were doing something different. And it's those safety practices that we can actually see and understand to say, hey, this is going on, and it's not what we thought. We just thought everybody was doing it the same. And you just make those kinds of assumptions. But when you actually look at the data, you can find an awful lot about safety practices and best practices that people are doing. And to me, that is one of the most invaluable parts of IIoT.
Well, this is a great example of how technology complements processes in a company, where when a process is implemented, technology actually helps retrofit and fix problems and gaps that are in the processes. Now, one thing really important to safety is regulations. Usually, anything related to to safety in a factory floor is regulated and overseen by authorities having jurisdictions. The question that I have for I don't know if Tim, if you're more familiar with policy, or any other panelist, is how is technology being accepted by regulators when it comes to safety? Usually there are processes that companies follow regulations. But at one point, will regulators accept technology as part of the normal process for safety in a factory floor?
Yeah, just to start the discussion, this is a pretty complex topic when we talk about the regulations around it with the technology itself. In general, we've heard some consternation, especially when you talk about the technology's AI enabled. It's a black box to the regulators, especially in policy land. They don't really like to know that it just goes into things, something happens, and out comes something good. What we do see, so a real example to have this in context is robots and what some of the sensors and algorithms have done in the world of cobots. That has certainly driven adoption of cobots into factories, the advancement of regulations, and the policies really are a little bit lighter there. It's more about IEC on some of the electrical stuff, along with groups like A3 that are working through the standardizations of the robots and the safety around the robots. And what we have seen is it's gotten a lot closer to the end effector as a robot, for an example. So it's not just that we have arm links plus some extra coverage, and you're talking about proximity, you're talking about radiuses and stuff like that. We're talking about pressure that's now determining whether a robot can stop or not. If you can do that, back to Dean's point, if it's a 15.9 seconds per inch or whatever, this might be, a quarter of a pound foot, kind of thing, that once those pressure sensors are being detected, the system itself as a technology are able to stop a robot. And that's kind of what the regulators and the standards bodies are looking for. Is the technology effective and responsive enough to get the end goal, safety in this case? So the best use that I've seen practically are the cobots, and how both worlds, a little bit of policy, both in the regulation, coming from 2 or 3 different bodies that are allowing these technologies to go. I've yet to see a pure technology have a regulation over it, though I think if, for us in the U.S., we certainly are hearing, for example, the White House talk about AI as policy.
Perfect. Thank you very much, Tim. Now, we've been talking so far about the implementation of the technology. We have seen the promise of smart manufacturing when it comes to safety. So let's transfer a little bit the conversation about the challenges and even risk that are involved in implementing these type of solutions, like technology solutions. So the first question is an open question for you, for all of you. Probably, Mohsen or Paul, if you want to jump first there.
Yep.
Do you see any challenge in the implementation of these technologies?
So one of the very practical challenges is the volume of data that needs to flow from the plant floor to the cloud. It's a significant data flow, and there is real cost associated with that data flow, and there's real complexity associated with providing those data flows in a secure manner. Today, we typically have a degree of connectivity from plant floors to the internet, but it's not a level of connectivity that's really going to support the massive volumes of data that we're potentially going to need. And then from an operational perspective, we've really not thought through yet all of the real issues around ownership of that data. We're talking about safety. We're talking about a situation where an individual's personal data is being used in part to provide protection, to provide safety to another person. And we're talking about information from one manufacturer being used to protect an employee from another manufacturer. So we haven't really worked through all of the privacy, all of the data ownership issues that go with the use of that massive volume of data that's being fed up to the cloud.
Right. Now, when it comes to privacy issues, is there any something to stop there, like to prevent the deployment of these technologies?
Well, I'll hit that from a European perspective, based on my accent. In Europe, we have some very, very strongly worded regulations called the Global Data Protection Regulations. And they put a huge responsibility on the processor of data to protect the personal privacy of individuals. And they also give the individual the authority, the ownership of their own personal data, and the expectation of explicit consent to use that data. So those regulations, they are both an enabler and an obstacle. We have to work out how to work within them effectively.
Right. Now, when it comes to implement the technology itself, and that's probably a question for Mario, you have experience, Mario, in digital transformation. So is there a challenge when it comes to using legacy processes and technologies and the move toward smart manufacturing when it comes to safety?
Yes, there's a big challenge. I think it's quite related to what Paul was saying here now and what Tim mentioned before, because the big challenge is the amount of data is this huge amount of data has to be stored, but it also has to be it has to be moving in real time. It has to be processed in real time, and there is also the modeling challenge, because modeling data is a challenge on any situation, on any kind of market, and this is totally new. For example, when you're modeling data that you're mixing information from sensors, information from events captured by video, and information coming from other machines, and then all this information together, you have to model in a proper way so you can take advantage of it in the data lake and with machine learning. And I don't think there are many cases of how this data is being modeled so far in the world, and also how to provide this to solve two situations: the real-time problem, like Jim was talking about, and let's say the analytics problem.
Got it. Thank you, Mario. Now, let us follow a little bit on that, on the thing of legacy and the integration and implementation of more new technology. One of the main concerns that I would have as someone implementing smart manufacturing in safety is reliability. I know that I can count on a person to look at a problem, record it, or even found a solution, or even record the data. But when it comes to safety, how can we guarantee the reliability of the devices capturing that information? And I don't know, Dean or Mohsen, if you can talk about that, like you are familiar with technology as well. Dean, if you want to start with that, so you know.
Yeah, I could tell you one of the problems that you have isn't just the fact that you're trying to gather the data and be able to process it so that it can be used for safety applications, but also the timing of it. If you look at a lot of the applications, it is not a single device that is reporting the data, and it's not even one single control. I may have a control on, let's just use stamping as an example. You can have a stamping press, and you can have that processing a certain amount of data, and you can be in its real time, but then you're uploading packets at a certain rate. Then I have a feed that's also telling me other information of the potentials that the rolls are getting slowing down because as it's trying to push in, there's some resistance in the die. So now you have information coming from 3 different devices that you're trying to time together to really gather that information. Is this happening because of this? Is this happening as a post-process? Is it a problem that I'm looking at in the tooling itself? All of these together, we need to have a good way to sync up the information that we're gathering, and it's only as fast as its weakest link. So whatever the slowest one is, if you're trying to sync them up, you're only going to be able to have the data in as real time as the slowest device is. Because when you start syncing them up, I can look and process this one, I can look and process this one, and look and process the third one. But when you try to put them all together, your analytics can only do what they can do as fast as the slowest devices. So there are some opportunities at a local level doing a very internal loop, and then the broader thing, which is trying to give you data as far as procedures and policies and things that you're doing here and how you can improve them to be safer.
Yeah, thank you, Dean. But that makes me think then in the implementation of those sensors that roam around the factory floor, like the wearable devices that employees could use. So how operations manager can deal with that? Like, are those reliable? Like, should an operation manager really think in using wearables in the technology solution for smart manufacturing, or should wearables believe it as a last option?
I can add to that reliability. In general, reliability always came into the picture after performance. Means that when you have the technology, what you are concerning is that is this performing what should be? For example, are these wearables perform in a way that they have been designed, which is normally happen through testing and some sort of validation, which is a common practice. And when they implement it, at the next level, there's going to be a reliability. Means that, okay, how much these information are going to be reliable as time passes, means that over the time. And the next step after reliability is going to be durability. Is that is this information that I'm getting is the same as the information that the same variable is going to provide me in the next year, or as the device is going to be torn and somehow used over the time. Here, the standard testing method, a specific routine of evaluating the performance based on the process that is supposed to be can help. Here, standard can introduce in order to measure based on the different scenario, and normally by some sort of exposing some stress test condition, like, for example, if this device is supposed to work in a high temperature or high humidity or excessive force environment, some excessive stress test condition exposed to make sure that during the time, how would these devices to somehow validate that reliability. I can say that for some of the technology which is implemented in Internet of IIoT, we have these procedures specifically for sensors. But as we are moving into more software based, we need to make sure that to bring some sort of functional safety aspect in order to create that reliability. When we have a artificial intelligence, AI, machine learning, the functional safety can add value for the reliability as well.
Thank you, Mosen. And it's good
Hey,
to
Edgar.
Sorry, go ahead. Tim, or who was?
Yeah.
Yeah, Tim, go ahead.
It was me. One of the things Mosen just hit on is really important. We have seen, and just recently this week, the way suppliers and the manufacturing technology providers are describing this, they're moving away from just talking about time-stamped events. And there's now pure middleware players that are supplying time series solutions. That's the language they're using. They're not talking about just a format data frame that we capture date time stamp. They're talking about the things that they can do over this time series as a solution. And they are talking reliability. So these things are starting to get through the market. And at least the market's responding, I think, to some of the issues that we were starting to bring up earlier this morning or today.
Thank you very much.
I would say also.
Sorry, go ahead.
I would say also about the reliability. I think it's also related to how you combine things, because usually the wearable sensor or the video will be reliable, but how you're going to put them together to contextualize and normalize. Like Dean was saying. So, for example, if you have for monitoring if something is electrified or not, and you want to check with the video if there is someone touching there or not. So if there is a delay between this information, and then you lose reliability in the combination of both.
Right. Thank you, Mario. Now, we were talking about reliability. What about safety? Because, let's continue with the topic of wearable, although it applies to other type of sensors. But these devices also have batteries in it. Like an employee that before didn't have that battery close by, now is carrying a battery with him or her. How do we deal with that? Like, is there any additional liability for an employer putting that into place?
Well, I could argue that we've been dependent on batteries for many, many, many years with safety. An obvious example I would think of would be a mine, where the primary form of person-to-person communications is through battery-powered radios. It's always about policies, it's about technology, and it's about procedures. It's about our behavior. What we have to do is we have to ensure that our behavior keeps the equipment running, keeps the equipment reliable. Again, just as mines have always had practices about how you recharge the batteries, how you ensure that you've got continuity of communication and operation. So it's a question of taking lessons that we have known for decades, for centuries, and applying them to this new technology.
Thank you, Paul. Now, when it comes to behaviors, wouldn't the implementation of smart manufacturing also impact the awareness that employees have of the factory floor, or the workers have of the factory floor? In that sense, wouldn't make it even more dangerous for the workers themselves? I don't know if I explain myself with a question. Like it's like when I'll give you an example, an analogy. I realized at one point that I almost hit someone when I was backing up because I forgot that I have to look to the back when I'm reversing my car. I learned to trust a lot in my little camera that I totally forgot that. And one day I was driving a car that didn't have that and almost kill someone. So that is in like how employers can take that into account. What measurements can they implement to avoid that to happen?
I think it's, if you're talking about over relying on technology, I think it's interesting.
That's the word, over relying. Yes.
Yeah, and I think if you look at there's a process. If you look in Japan, when they're showing, they use a process that when they're looking at something and they actually do a visual inspection, like on their trains, that the conductor or the engineer takes their finger and points, and by doing that, it triggers something in your brain to follow that I'm actually doing this, and you're more aware. You're not just taking a peripheral view, you're actually doing this. So in that case, I think that by implementing procedures so that we're not just doing the things that we're not just relying on the electronics that we have, as Paul had mentioned earlier, using augmented reality. We've talked about this before, of using a headset or just the glasses where I go up to a machine. And now, because I'm wearing these eyeglasses, I can see where the hazards are. But that triggers you to know and make you aware of where the hazards are around the machine. But does it really reinforce the procedures of not putting your hands into these areas? So you still need those procedures to lock in that same action. And I think we need to develop those, whether it's through an infrastructure or just whether it's company to company or globally we define what those are. I think we have to have more and more of that to make sure that we are reliant, not just falling into the habit of relying on this technology. Because as you see in vehicles being self-driven, okay, to what, I'm sure everybody's seen the video from the Tesla where they're coming up to a buggy in the Amish country and it can't distinguish what that is. It doesn't understand what it's behind because it wasn't programmed into the system correctly to say, hey, this is what a buggy is. So we have to still rely on human beings in an awful lot to perform safely.
Thank you, Dan. Now, let's think on the other way. Now that many companies are losing people, like people are leaving what they call the Great Resignation, is there an advantage of having a smart manufacturing in my factory floor to kind of supplement, kind of avoid that to happen? I see you all nodding and saying yes. So if one of you would like to start with your thoughts about it.
I think nowadays many people they are seduced by like the startup environments, and so they can work from home, they can have flexible hours. And the problem in manufacturing, people are still dictated by the timing of the machine. So at least for those people that are not operating a machine, to be able to have this flexibility, I think it's a great thing to help on keeping the talent, retaining them.
What about the skill set? What about what people like the time that it takes for someone to learn processes in the factory floor? Can that be minimized by the use of technology?
Well, certainly I highlighted augmented reality, virtual reality, and I'll tie that in with simulation, which can all be fabulous tools to accelerate the learning process. But not just to accelerate the learning process, but also to reduce the need for a learning process. One of the problems that people have is that we learn stuff and then we forget it. And one of the advantages that computers have is they don't forget stuff. So by being able to work people through various processes and practices, maintenance interventions, through presenting them with simulation of how that operations through augmented reality, overlaying the steps that they have to take. What we can also do is we can reduce the need to train someone before something happens and be presenting them with the information about what they need to do as they need to do it, rather than 3 years ago when we forgot.
Right.
I would echo that sentiment. One of the things that I would say is that as a challenge that we have is we now have technology where we can track where people's pupils are and where they're looking. So if you're working around a piece of equipment and you see that this operator isn't looking where their hands are, or they're not paying attention to what they're doing, you can then devise a coaching or retraining of the individual to say, here's why you're looking here. Or we can even develop technology to alert them, catch their attention, things that will draw their attention to where the hazard is, or draw their attention to where they should be looking or what they should be paying attention to. One of the downsides is manufacturing is loud in some cases. Some of the plants that I go into, you're talking about 97 decibels. That's not the perfect environment to train people. Kind of to Paul's point is, if I could train in a virtual environment, that has a lot of advantages. I can make it as quiet as possible, or I can make it as loud as possible, because I can control that environment to train them in. But if you sent your kids to school and they had to learn with earplugs in and yelling over each other at 97, you would never accept that. But that's what we do every day in manufacturing.
Do you think, and that's a question also do you think that there will be one day where there won't be any physical person in the factory floor?
We're moving
across
in that
the world, or in certain factories?
Good point.
I mean,
let's put it in the industrialized world. And Tim, in the industrialized world.
Sorry, go on, Tim.
Go ahead, Tim.
Yeah. You know, if you have a chance and you go to the foot of Mount Fuji and walk to the FANUC facilities, they do that today. And there's robots making robots, and there's no one around, and they have many reasons for doing that. But they also have a great culture for the people who do work there. So I mean, there's a good balance, I think, of what we're doing. And I think we will get there out of sheer demand. I believe with resignation as a background, you know, what we see in general under any circumstance of a recession, automation sells. I think we're going to find that some of the automation is also going to attract people who would not have otherwise known about manufacturing and been interested, because it wasn't a manufacturing job, it's a coding job, or it's an integration job that they didn't realize. You know, working in FIRST Robotics had a pipeline to do something else other than play on a high school gym and win some awards. So anyway, I think we will get there in certain areas. I don't know, just because of the sheer nature of how we make things in the world, that it has to be every factory, or that it will be every factory. But there's ones that exist today, like FANUC.
Good. Now, one last question, because we're almost out of time. And it's related with the supply chain issues that we're having now. If I am a manufacturer trying to start the implementation of these technology solutions in my factory floor, what are the things that I have to be concerned about now respecting supply chain? What are those things that I have to be aware of? And Paul, you're probably more familiar with devices and supply chain, so if you want to start.
Okay, I mean, this is a difficult problem, because the problems are real, and we would have all fixed them if we knew how to fix them. So the simple message that I actually give to people is, if you can't start big, start small. If you can't implement the perfect solution today, implement one that makes things better. Don't look for the 20-30% improvement overnight. Look for the 1-2% improvement. However difficult things are today, it's not an excuse to do nothing.
That's a great advice, Paul. Well, time is up. It went fly really, really fast. So we have some questions from our audience, and let's hear from them, and then we'll regroup and answer them. So back to you, Katie.
Thank you all so much for that great presentation. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it into the Q&A window and hit submit. We will get to as many questions as we can today. If we do not have time for your question, do not worry. We will reach out to you following today's session. Edgar, I'm going to pass it back to you and the group to answer some of our attendees' questions.
Thank you, Katie. So we have some questions from our audience, and we have selected a few of them so our panelists can answer it today. The next one will be answered later in the chat in the panel recording. So the first question is, why should one monitor vital signs instead of relying only on computational vision? Mario, do you want to take this? Yeah.
Yes, please. Thank you, Edgar. So, computer vision is evolving a lot. It's been pretty fast. So, if we think about like 15 years ago, when people were talking about like self-driving cars, they were putting sensor on some parts of specific roads, so they would test some self-driving car that would rely on sensors. But nowadays we can see that computer vision is coming here to simply be the dominant technology in this area. But for example, it can be actually so precise. Wearables, for example, they can be very precise to the point that consumer devices like a smartwatch can detect if you're about to have like a cardiac problem. And if computer vision detects that the employee, the worker, fell down, for example, it might not detect why, and this can be quite complemented by the wearable.
That's an excellent point. So it's kind of a complement. Basically, it has to do also with reliability.
Yes, reliability.
Fantastic. The next question says, how does an organization balance data monitoring versus compliance with privacy norms, such as GDPR?
Edgar, if you don't mind, let me take this. This is really the background of data governance, and data governance is our behavior, humans' behavior around data, and the policies that need to drive that. And the way we see the data is really solving, quote unquote, the problem at the lowest level possible. You can think of this as a military or in a corporate structure. And to the extent that the data has to be assigned to a person, then what we want to do is drive as much anonymity or masking of that data, and then be transparent with our policies. So let folks know the why. The whole reason you start this whole entire project is with the why, to make your job better. And if you can show that you are transparent in your policies of how you do that, and then be accountable, let them see how you're accounting to them, that you are doing what you should with the data. And those policies exist. That way you have a fighting chance to balance the data monitoring side, which is we really want to monitor everything, which by the way you don't, to the extent of privacy. Is everyone going to watch me everything for everything that I do? And the answer is no, we don't. Right. So there is the balance, and I think the data governance is the way to do that.
Thank you, Tim. Okay, the next question says, can sensors change your process of safety?
I can answer that.
Thank you, Mohsen. Go ahead.
The answer is definitely. Considering the advantage of the capability that sensor bring into the table, it's going to make so much change in the way that we are going to deal with the safety. One of the main characteristics that brings, or let's say the advantage, is the real-time data that we are obtaining from implementing sensors in the working environment. And this is going to give us some sort of tools in order to deal with the safety hazardous incidences and location. The other thing is that the capability of that with different usage of the sensors. They are placeable, which was the traditional, but as the technology advances, the wearable sensors and implantable sensors are going to provide some other tools. For example, one of the trends is that using the smart helmets, by implementing some specific sensors inside of the helmet, imagine how much capability you're going to gain with regarding the information that you can propose or gather through that helmet. If there is any force, if there is any fall, or if there is any incidents that happen to the workforce who has that helmet, you can gather the information. And also the preventive measure that you can implement by all of these data that you get from sensors is going to be another level. The type of analysis that you do, for example, if something happened, immediately call emergency, and the procedure afterwards can trigger immediately. So definitely sensors are going to revolutionize. It's already started happening at the manufacturing, but as the technology advances, we are going to see more advancement in the way that sensors are going to impact safety in the work environment.
Fantastic. Thank you, Mohsen. The next question that we have from our audience is, Is IIoT your primary safety tool? If not, can it be?
So I'm going to jump in there with a nice big round no. And there are two reasons that I'm going to throw that no out there. The first one is we want to use IIoT to increase safety. And the first thing that you do to increase safety isn't to replace everything that you've got. You find things that add to the safety that you've got at the moment rather than to replace. Second thing is that when we're thinking about safety, we're not technology driven, we're risk driven. So what any manufacturer should be doing is they should be looking at the risks that their workforce are facing. They should be evaluating strategies to minimize that risk. And if IIoT is part of the solution, that's great. And if IIoT isn't part of the solution to mitigate those greatest risks, then you need to look at other technologies, other approaches. So don't be technology driven, be risk driven in your thinking about safety.
Thank you, Paul. Now, the last question that we selected from our audience is, how do you identify safety risk using IIoT? And is society ready for that type of intervention?
I can take that, Edgar.
Thank you. Go ahead.
I don't think that safety and IIoT exist in a bubble. We have to start with understanding our processes. And the better we understand what it is that we're doing and what's really important, we can then assess how we want to apply IIoT to that. As Paul had mentioned, the key is mitigating or reducing or eliminating, hopefully, risk. Now, OSHA, as an organization, one of the things they look at is first engineer it out so that you're not exposed to it. How do I engineer things out? IIoT can play a great role in understanding, once we understand how we want to apply our sensor or some type of vision system, then we can apply it, and then that will then start to track what it is we need to understand better. Because I think a lot of times we assume we know what's going on, and we assume we understand what the risk is. But sometimes it doesn't, until we actually apply a sensor or put a vision system in place, we don't actually see how it's happening. And as far as are we ready for it, I think we are, because the number one problem is injuries. If you're talking about eliminating or reducing injuries, if we can find a way to do that, yes, why would you not want to save somebody's finger? Why would you not want to save someone's life? These things are, when you see that happen in real time and you've actually been to an accident investigation, I'm telling you right now, you will jump through a lot of hoops to try and find a way to keep this from happening again. And I think when we start looking at sensors and how we can apply them to do that, to help us understand how it happened and understand why things happen, we can be better at what we do to eliminate that.
Fantastic. Thank you, Dean, very much. So that concludes our panel today about industrial safety and smart manufacturing. Thank you, Paul, Tim, Dean, Mario, and Mosen, for being here with us, sharing your experience and knowledge with our audience. And thank you to you and our audience to share your time with us and learn and ask your questions. And we hope to see you again in the next panel. Now, to Rockwell Automation, thank you very much for working every day to make smart manufacturing a reality. And from Global Spec, thank you to the million of technical professional engineers who have allowed us to connect them to the parts and services they need for project success. So Katie, now back to you.
Thank you, Edgar. Now, just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Defining the Smart Manufacturing Journey series. Today was session 3 of our 4-part series. Please join us for the rest of our sessions. You can visit our series page using the link listed in the resource widget. Sign up for all the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with all of us today. You will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or even share it with colleagues. Again, thank you for taking time to attend this Global Spec series. Take care, and we will speak with you soon.